Hello children, welcome back. So now in this video we will just do the continuation to our previous video. What was that? Formation of image by a plane mirror, and now it is for an extended object. So in our previous video we have seen point object. Now we can see the formation of image by a plane mirror for an extended object. Sir, what was this extended object, sir, again? Okay, let us see. Extended object mean like you only, right? A person standing in front of a plane mirror. How do it cast an image? So you can see from top to bottom of your body, entire everything. When you see stand in front of a what do you call this, dressing table and all, mirror, etc., right? Makeup mirror, or so that one we are just going to see. Extended object can be of any building, or extended object can be of like a tree. Extended object can be of a long scale. Anything you can say. That was your extended object placed in front of your plane mirror. That's what we are going to see now. Clear? Chalo. So let us see this one now. So this is your plane mirror, because now the silvering we have considered over here like this, and as usual we know this is your reflecting surface. This was your reflecting surface. And now we would like to consider our extended object. So say extended object, I can say some height h was, it will be there for it obviously. So person will have some height h, right? So say this is your extended object. So representing the top of this extended object with an arrow mark over here. So now I can label the object as A as your top and B as bottom in this kind. So now as usual again we are supposed to take two incident rays, right? So I would like to take the two incident rays as one incident ray. I would like to take straight incident directly onto the what you call this mirror perpendicularly. In this kind I would like to say this one. So like this. So along the normal it is going to be incident. So if I consider the normal for this one, though, it will be in this kind. So normal for this one will be like this. See. So this is your normal directly. So it was incident on the normal only in this way. And similarly one more incident ray I would like to consider over here. This incident ray is also the same kind. Was incident again on the normal as usual as the first one from the top. So this is once again your normal. Now one more incident ray we need, right? So that we can find out your what you call what, so the reflected, I mean like image formed we can say. See, the next incident ray I would like to consider in this way. So like this. And one more incident ray over here. So we got now 2 more point of incidences straight away. And at those point of incidences, if I draw a normal, it is going to be like this. Exactly, this is your normal. And similarly here also, this is your normal. And as usual you know what to do, right? You will be measuring the angle of incidence and as well as the angle of reflection. You need to find out actually. So this is your angle of incidence I1. And now what happens, this one for angle of incidence I2. Sir, what about the reflected rays for or angle of incidences for the light ray incident? So straight, sir, this one. As they are incident on the normal, I say that angle of incidence is equal to angle of reflection, that is equal to 0 degrees, and here also I is equal to R is equal to 0 degrees. So they retrace the same original path behind. So they got retraced behind. So this is one of your reflected ray. And the second reflected ray for this one, I'm just taking an approximate value and say this is your angle of reflection R1. So again I1 will be equal to R1. And similarly here one more reflected ray from this directly, and this is going to be again R2, and now this is I2 is equal to R2. So again you also can see that the two reflected rays of both top and bottom are not at all meeting directly. So as a result, what I can take straight away, we can just extend them behind. We can just extend them behind directly. So let us extend them behind now. When I extend them behind, so this is one kind you will be having, this is one more, and here this is one I can get, and from this another one I can get. So therefore if I see clearly, this is your top of the image and this is your bottom of your image. So if I can just join those two straightly, directly I am going to get an image. Done. So this is your image casted by your plane mirror, and this is your image, and we consider this one as your object. And say what I can understand now clearly, it is so parallel. So say this is your height of the object HO, and I observe this is height of the image HI. So what I learned here, one more characteristic added over here, that is previously we learned it is a virtual image, and also we learned that object distance is equal to image distance, and now the third one we are learning is height of the image is equal to height of the object. So thus the characteristics of image formed by a plane mirror are, it forms a virtual image and its object distance is equal to image distance, and also height of the image is equal to height of the object. And most importantly, there is one more, what you call this characteristic represented by plane mirror, that is lateral inversion. Sir, what do you mean by lateral inversion, sir? See, you might have been observed in your day-to-day life examples that when you stand in front of a mirror, you raise your right hand, seems to be lifted left in the image formed with a plane mirror, exactly. So that opposite direction or opposite orientation you observe in an image. So mirror image will be saying. In mobiles also, selfie, when you take mirrored selfie we will be taking. The reason exact meaning of that is, if you lift your right hand in a camera, it lifts your left hand in your image. So that's what your technique called as, process is called as that lateral inversion. So these are the four important characteristics of image formed by a plane mirror. So I hope you all understood, children. Please do text me. Don't hesitate if any kind of doubts are there. Thank you very much. Have a great day.